Hi everyone, I'm Oliver from Lenses.com, and what you are seeing right here is some tests I did with the Ocean Simulator in Blender. In these tutorials, we are going to see how to use the Ocean Simulator to achieve an effect similar to this one. This test you are seeing right now uses also the foam effect from the simulation. And well, in this first part of the tutorial, we are going to focus in the simulation itself. Okay, so we are going to generate an ocean and check the parameters it has more or less. And in the second part of the tutorial, we are going to learn how to shade it and how to create the final scene, apply the foam effect and everything. So let's go for it. Here we are in the basic scene with the cube. And ocean simulation happens as a modifier. So we need to add the modifier from here, right? Let's make sure we are in the modifiers panel. And here in the simulate, let's pick ocean. And as you can see, it replaced our object with an ocean simulation. This happens because we have selected the mode generate. All right, we can generate or we can displace. Displace will pick our mesh and we'll displace it to simulate the ocean. Generate will generate the geometry, replacing anything that we have in that object. All right, so they are two different methods. We are going to see how the simulation works with the generate mode, and then for the final scene, we're going to use the displace. And at that point, I will explain to you what are the benefits of using the displace mode. Okay, so let's take a look at the parameters we have here. All these parameters are for the ocean simulation, sorry. And well, we have here these two repeat parameters. This is basically they are only active in the generate mode, and this is because they will generate more geometry to repeat the same ocean once and once again in each axis. So as you can see, we can achieve a bigger ocean, but the actual simulation is only a part of it. The other ones is only a repetition. Then we have the time, which is one of the most important parameters because it's the one that makes everything to move, right? I have received some questions over time that, hey, Oliver, I have done an ocean simulation, but I can't do it, make it move, okay? So we need to animate this time value. So you can see if we move it, we see kind of what the simulation looks like over time. Okay, so later we are going to animate this value so it makes the ocean move. Now, increasing the resolution will actually, let's take the repetitions out. So if we go here, you can see that the generated mesh has the number of polygons needed for the current resolution of the simulation. If we increase it, it will also increase the amount of polygons. So as you can see now, we have a more detailed simulation, but we have also a lot of polygons. So we need to keep that in mind, right? I usually use around 15. It's okay, but in this case, we have a very small area of the ocean. So if we want to make it bigger, we are going to handle that later. Now, the depth represents the depth of the floor below the surface. So if we put it on 0, this won't move. If we move the time, so you can see it won't move because this is just like if the floor was right here. So there is no movement. But let's actually animate this already. Let's put it on 0. Press I to insert a key. Let's go to the end of the animation and let's put something like 6, for example. Depending on the rest of the parameters, this time will also vary, right? Because we can add different values here and the simulation will change, right? We'll give the impression of slow motion or it will be really fast. So we need to keep in mind that depending on the rest of the parameters, we may want to change also the time values. Right, so now we have an animation. So if we press Alt-A to reproduce, you can see there is nothing because we have no depth. If we start increasing the depth, you can see that there is some little movement. And if we put it really below the surface, you can see that it's changing. Now what's happening is that at the beginning it begins accelerating the time and then decelerates. What we need to do is to open here the graph editor, just select these two vertices. This is the time animation curve, and pressing V, we put it in vector mode. So now it's a linear animation. We can drag this down to make it full screen again. And now we have a constant animation. It looks a little slow to me, so we can just go to the last frame, and here let's add like 10, for example. Okay, this kind of looks better. Let's a little more up so we can see it over the grid. Okay, so we have this ocean, and now we can start playing with things. Now, the size is the current size of the simulation. All right, so it usually is good to have it in 1. As you may know, in simulations, it's very important that we keep in mind the size of the objects. So it's important that the object we use for the simulation, and you will see it better than when we go to the Displace mode here, we need them to be in size 1. Otherwise, we would need to play here with really high or really ridiculously low values because the size is not correct. So the size should be 1. We can increase it, as you can see, but the waves now are like, you know, they don't have the same amount of detail. So it's just a matter of playing with that if you want. And the spatial size is the, if we have this plane, it will represent that this simulation has the 50 meters each side, right? So this is the number of meters that the actual simulation is taking in account. So if we increase it, we'll also increase the size. So they are two different values that, I don't know, I recommend you to play with them until you get the desired result. Now, the random seed will make everything start again and generate a random ocean from scratch, right? So each time you change the seed, it will be completely different simulation. Of course, it's just an ocean, and if the parameters are the same, it will look similar. But, well, you can get something a little different in case something you don't like something that is happening. Now, the choppiness. This is probably my favorite parameter of the ocean simulator in Blender. The choppiness makes, as you can see, that now it's in 1. Let's put it on 0. So if we go to the top view, you can see that everything is just square. The simulation is only happening in the set value, right? In the height of the mesh. The vertices are displacement up and down, but not left and right, okay? Or you know, in the depth. So with the choppiness, we achieve the effect that the vertices also move in X and Y, giving a more dynamic sensation to the ocean, and also it achieves very interesting effects with waves. So let's try it. If we start increasing it, there we go. So as you can see, now we have, if we go to the top view, it's also moving in to the sides. As you can see, we can get the waves sensation. You can see here how they reflect and everything. So it's really really cool. I like this value a lot, this parameter, because it can let us see the peaks of the waves. Okay, so now alignment. This is another interesting parameter. This will make the waves go in a single direction. Right now they are happening just they are, you know, in the middle of the ocean. They have no direction, but if we are near the coast, we probably have some waves going on to the coast. So we can increase the alignment value, and as we increase it, you can see how the waves go in a direction. Now we can change here with the direction how to where the waves are going, right? Something like that, for example. Now with the scale, we can increase or decrease the size of the waves. You can see that some crazy stuff is happening, because as when we change the scale changed the vertices in their normal. And we have choppiness moving in X and Y the vertices. When we scale them, they may intersect like that. So in that case, we should just go ahead and decrease a little the choppiness until we get something that is working better. Right there, we still have some intersections, so we can tweak it a little, just a little bit. Okay, something like that. Oh, something went down in my house. Okay, and now this is the damping. This is something that is difficult to understand exactly what it does, and it's not that difficult. If we put it on 0, you can see how the waves go in a direction, but there are waves that reflect that direction and go in the opposite direction. But if we put it on 1, everything goes in the same direction, right? So this depends on what you want to achieve with your simulation, right? It makes basically what I just said. Some waves, when going in this direction, collide with other waves and go back in the opposite direction. As you can see, if I at 0.5, which is the default value, it works pretty well. Okay, it gives the impression that the forces are pulling in that direction, but something is making the water stay in its position, which in my opinion looks great. But if you want to achieve a different result, this will make everything move in that direction, but also in the opposite one, because the waves are reflected. And I think I spent too much time just explaining that single parameter, which is really basic. But well, I hope you understand it. So I will let it in 0.5 because I kind of like it. And now there are other 2 different values, which are the one velocity. This is a little difficult. It's very little differences when using it. And it basically defines the wind velocity, which is sadly what its name says. But the effect it has is that if we increase it a lot, instead of these small waves, we get we get bigger waves. So let's put something crazy like 300. Let's see what happens. Even more, 1000. Let's see if we can see the result. See, apparently it's very difficult to see the difference with this parameter. But if we put it on 0, nothing happens. Okay, so it's indeed important. But as you can see, we have something crazy going on. By the way, then I'm going to tell you how to this simulation, this ocean simulator, is really interesting to get. So as you can see, with small values, we get very little waves and very detailed. And as we increase it, we get bigger and less detailed waves. But well, it looks like it only has effect when we play with little values. Okay, so this would make for a stormy ocean. Okay, which looks great. You can achieve really cool effects with this simulation. What I wanted to say before is that this modifier is very useful to. I used it once to model popcorns, which is not really, intuitive. You wouldn't use an ocean modifier to create a popcorn, but if you play with things, look at this. It looks like a popcorn, right? And if we decrease the resolution, okay, and play a little with the values here, we get something that can look like a popcorn. There you have it, popcorns. Right, we should tweak it a little more, but as you can see, it's kind of interesting to get some interesting results and abstract stuff. Let's put it on 50. There you have it, abstract stuff. This could be like a cloud, a cartoony cloud. So it's very interesting, not only for ocean, but you can do a lot of stuff with these modifiers. Now, what is the value I changed? 1. Okay, so I think we were using 2. Let's put the alignment at 0. Let's decrease the scale a little bit and increase the choppiness. Also put the resolution to something bigger. And well, this is not the perfect simulation, but let's say we're happy with it. We have these other values here, and you may be wondering what the bake ocean option does. And well, this is kind of simple. We can generate normals and generate foam from this ocean. And I'm going to explain you now what this means. When we bake the ocean, in this folder, we generate an image sequence that is that covers this range of the animation, and it will generate EXR files with displacement, right? Which is basically what the ocean modifier does, the displacement of this mesh. And the size of the image will depend on the resolution here, right? So I usually use, for the simulation, I just disable this, this modifier in the viewport and just bake it in a resolution something like 30 or so, because we get a slightly big image sequence. The resolution of the images is slightly big. It's not really big, but it's very useful. And well, in the viewport, a resolution of 30 is probably too heavy. Okay, so well, you may want to play with that. So when we bake it, you generate a displacement image sequence. But you get also, if you activate these two options, you get generate normals. I mean, you generate a normal sequence that gets the normals from this animation, which is useful if you want to use then the normal map for a video game, for example, in which you can just add a normal map into a plane and you get an ocean simulation, but there is no displacement because the mesh is probably not very detailed. So it's pretty cool. And generate foam is a very interesting option that we are going to use in the second part of this tutorial for making the foam material. It's something that I'd like to show you if I can here. If we go to display, let's put in texture solid, and here you can watch the foam. It's impressive. I love this one. The foam basically is something that happens at the top of the waves, okay? And we can increase its coverage here. There you have it. So basically what this is doing is to paint the vertices, right? This is vertex colors, and the simulation is painting the vertices to show us where the foam should be. Now we get an advantage here if we bake it, because if we bake it, we can play with this foam fade, which is a value that will make the foam to stay in the place and fade over time, and not just be painted when the wave is right there. Because it happens a lot that, oh, it wasn't this one. I don't remember the value we had there. Okay, so this is the coverage. So you can see if we decrease it a lot, only the top of the waves are showing the foam, while actually they would be at the top and then would rest on the surface and maybe fade over time. So we can create that illusion from here by baking this, and then in the render, in the second part of this tutorial, I'm going to show you the two options. You can use this foam, okay? You can call this like foam, for example, and you can access this this data layer from the compositor in the materials, so you can use this to mask a different material over the waves. But you can also use as a mask the image sequence you get from here with more detail, and you know, you have several advantages from using the Bake Ocean tool. So yeah, now I want actually, let's put a value that we are going to use in the next tutorial, something like this, for example, right? 2.80 or maybe 0.3, that's right. And let's just save this as ocean. 0.01. And okay. All right, so we have this saved. Now I'm going to show you the other option with the Displace option, and you will see the differences and the advantages we get from using the Displace instead of this one. Because this one, as you can see, I could decrease a little the resolution and make a bigger one. But as you can see, we get a lot of repetition here, and also it's like crazy. You can see that now the frames per second just decreased a lot because we have right now a very high amount of polygons. Okay, so this can be useful sometimes, but I recommend to use the Displace mode. And let's actually stop the simulation. Let's create a new scene here. New Displace. And now for the Displace, we actually need to use a plane. So we create a plane, and to this plane, let's add the ocean simulation modifier. As you can see, it also increased the size, but now this is in generate mode. Let's go to the Displace. The Displace, as you can see, we already get a difference, and is that it takes the actual size of the object. It doesn't multiply it by this spatial size. So what we need to do is to make this bigger, maybe 50, right? So now we get the right measures here. And what we need to do here is to go ahead and press Ctrl A and apply the scale. This way, if we go here in the scale, we get 1 by 1 by 1, which is as if this object has this actual size, because otherwise here it's 50 by 50 by 50, which is just right after we scaled it, right? So if we apply it, there we get 1. Okay, then the next step is press tab to go into the edit mode, press W, subdivide it, and make a few subdivisions, because this is a disadvantage of the Displace mode of the ocean simulation, and is that we need the actual mesh to be really subdivided. Let's now go back, add a subdivision surface, put it on top of the ocean simulation, and increase the amount of polygons, subdivisions here in the view, and put them on simple, because we don't want to smooth the surface. We just want to add more polygons. Okay, so now we can just go ahead and select the graph editor here and start with animating the time, so we can have a real-time feedback on the simulation parameters we pick. So let's put this on something like 10, for example, like this. And as we did before, go here, press V, and select vector. What's this? Here we can already see how it's moving, but we go right here. Now we can just, let's try to tweak a little the parameters. Let's increase the choppiness, as I love the choppiness. And here, let's try to scale it a little more. So you can see how it's repeating. And now we are going to do something, we're going to build a scene actually. So let's press Shift A and add a camera. And the camera, let's place it something like here. There we go. Can move it with this, like with Shift F, the fly mode. And what I'm gonna do is to go to the top view. Here you can see the amount of polygons we have. We can increase it and have a more defined simulation. We can also increase the detail of the simulation, and here increase even more the subdivisions. Okay, so you can see the more subdivisions we have, the more polygons we have, the more detailed is the mesh. An advantage we have here in the Displace mode is that we don't depend on the resolution of the ocean. We can have any amount of resolution, but the final result will depend only in the amount of polygons we have in the surface, which is nice because it's exactly what we need at this point. Now what I'm gonna do is to pick this camera. Let's go here to the camera panel, and here in the size, let's pick a really big size, something like 300 maybe. And this is because now if we go to the top view, we have we can see what we see with the camera. So everything outside this cone is not visible by the camera. So right now what I'm gonna do is to just extrude this up like this. Okay, now just pick this edge. I'll explain you what I'm doing later. Let's stop the animation because now I'm modeling and I don't want the animation. So let's put something like this. Something like this. And basically, you can see how what I'm doing here is just, you know, maybe we can scale it like this. We are basically making a plane that covers the area that the camera can see. Because in this scene, we can see this. We see the ocean from the surface. All right, we are not going to do a shot from up here. From doing it from up here, we should just do it a little differently. But at this point, I prefer to do it this way because we are going to use it just to watch from that perspective. So it's exactly what we need. So we need to just cover that area. Now, here I'm going to divide this a couple of times. Like that. Let's also divide this. I'm dividing them with Control R and the scroll wheel to divide it even more. So if you pay attention, what I'm doing is that I have more divisions right in front of the camera than up here. Here I just have a very basic subdivisions, but here I have more definition, and we are going to give it even more later. Now, what is happening here is that the camera can't see past a given distance. What we need to do is to go out from the edit mode. Let's go right here, and actually, let's do something here. Let's divide this like this. To have a feedback on what we see from the camera, but at the same time be able to work there. Let's put the perspective at 1 so we see everything black and we are not distracted by the fact that it's sending here. So this way we're going to only focus on what we are really seeing in the camera. And we are going here. And from the camera, we are going to increase the end clipping. And as you can see, if we decrease it or increase it, we change the amount of distance we can see from the camera. So let's put it on something really big, like 10,000, for example. All right. So let's press play to see what we have. And this is what we have. So as you can see, it's not really cool for now. So what I'm gonna do is to tweak a little these things. We can change the space. Okay, we can decrease it also. We can increase the size of the ocean. And if we increase the size, we probably have to just, you know, let's extrude this one a little more. Scale it a little more like this. Okay, so we would have something like this with the ocean ends almost in a line, the horizon. We have this. Now we can increase the scale to have bigger waves. Can increase the choppiness. And let's increase the resolution. The good thing about this is that we can increase the resolution a lot and only use it in a part of the scene. Let me show you. I'm going to select this part here. There we go. Which is closer to the camera. And I'm going to go even a little farther. Like this, for example. Okay, so it's almost the area that covers the camera, and we can subdivide it. So now we have much more detail around here, around the camera. We can go ahead and select the part in which the camera is. Just go a little farther. Select these ones also. Okay, and subdividing again. And we can go even farther and select these ones that are very close to the camera. And subdivide it again. So now this is something like what we have. Let's scale this a little bit to get bigger waves. Decrease a little the choppiness because some of the edges are being intersected. And actually select the ocean and the camera and bring it a little up so we avoid the grid. And we may check this the back there. Let's select this and scale it even more. Okay, so we have something like this, which is, I think, a pretty cool simulation already. For an ocean. Okay, and as you can see, it's just a matter of playing with the parameters. Okay, this, as you can see, can give a more fiery looking waves. Let's play with the alignment a little bit. Yeah, but we have a lot of issues there. So let's have a little alignment. Let's make this bigger. The good thing about this, as I said, is that we have the detail where we need it. Okay, as you can see from the top, we have a lot of divisions there right in front of the camera, but we have it much more light geometry as we go farther from the camera, which is really nice because it allows us to have different amounts of resolution at different points. As you could see, when we generated the geometry with the ocean simulator, what happened is that we need to have all the time the same resolution. With this method, we can change that a little bit and just decrease the choppiness. Can also increase the waves. So as you can see, we can play a lot with a lot of parameters here. Also, I didn't explain the smallest wave before, I think. This is the size of the smallest wave. Here, if we pause it, you can see that there are very small, like a noisy surface, okay? This is because the smallest wave is very, very little. If we increase it, you can see how the waves become bigger, like a more smooth water. Okay, but I actually like it to be like this. Okay, so now we have this. What we can do is to select it. And now I don't need to show you anymore the amount of subdivisions. Now, there are a lot of ways of doing this. Of course, there are a lot of ways. I've even done this with, for example, using the generate mode, but using it, let's say I add a layer that is in front of the camera with a lot of resolution, then I add another plane behind it with less resolution, and then a really big plane with even less resolution, and so on until the horizon. All right. I found this way to be much more efficient, but of course you have angles going on here, but well, as it's a really big surface and it's moving and all that, it's very difficult that you will find any problems with having triangles or angles going on here when you subdivide some parts more than the others. But anyway, if you really want to care about the geometry, you can do it if that's what you want. Okay, so this is basically a way of being able to have much more definitions in some parts than the others. As you can see, we can even increase it a lot more, okay, by adding here another division. So as you can see, this is even cooler, but well, it already takes a lot of performance, but for the final render it may be cool. Now for now, assigning the viewport and all that, this is the actual subdivisions of the geometry. So as you can see, if we go to the wireframe and we go here to the object options and select draw all edges, you can see that here we have more polygons and here we have less polygons, and this is a lot farther. So we are seeing these polygons bigger than they are and these polygons smaller than they are. But if we look from the top, you can actually see how the density of the mesh is changing along the surface. So yeah, it's that's the point of this method. So we can just smooth it out, and let's take a look at it. And at this point, we are seeing this real time. You need to keep that in mind, because if we increase this, we are seeing it not on real time already. Right? The animation is in 24 frames per second, and here we are seeing it at 19, sorry. So it's not real time, and if we increase it even more, we see it very slowly. So we need to just go back and see that if this is exactly what we like, then we could do it this way. So I think it's not bad. And also with this amount of detail, it's pretty cool. And here, as you can see, we can change the resolution at our will, and there will be no problem at all. Okay, something like that. And it's really nice. We increase a little the choppiness, maybe. Yeah, I love the choppiness. Decrease a little bit to correct that intersections in the top of the waves. Try to scale it a little more. Decrease the choppiness to counter effect. Okay, and I think I'm done for now. Let's try actually with decreasing the damping and all that. See what happens. So as you can see, this makes the waves collide with each other and then go back reflected. While if we have the damping on one, everything will go in the same direction, which is really, I think, unnatural. So let's give it a 0.5, which was the default value. And now finally, let's add another little detail, which is just animating the camera a little bit, because let's say we are in the ocean, we could just render it like it is, but I actually like to, have a little movement of the camera, because maybe we are like let's bring it a little down so it's more close to the surface. And let's say that the camera is floating over the waves, so it should be moving a little bit. Let's bring this down. Let's add a graph editor here, because we are going to make that changes in the orientation of the camera from the curves. So the first thing we need is, of course, curves. So let's add a keyframe here in log rod scale. Let's go to the final frame, 250. Add another keyframe with I, log rod scale. And here we already have some curves to work with. So we can just go to the set location. We press N, and at the bottom we can see the add modifier option. We add a noise, and if we press play, we can see how this got a little crazy because these lines, these curves are really crazy as well. So we can just increase the scale to just make it smoother. We can increase the strength. As you can see, we'll define the amount of movement that the camera has. So make this really small. And also we can select these two keyframes and move them a little up so the camera is higher and we can see better the horizon. Now let's play a little bit with these values. So with this button here, we can copy these modifiers parameters and go right here and play a little more with them. So the Y rotation will rotate it this way, will tilt the camera. So let's go here, paste it, and as you can see, we already have this, but it's way too brutal. So just let's pick a smaller strength. Now we have something. We can increase the scale here so it's not too strong, the effect. Okay, something like this can be cool. We can place the 3D cursor right there so we can see better how we are moving. Okay, and let's also apply it to the C location. So the C orientation, sorry, the C rotation, set rotation. As you can see, if the camera is moving left and right, it's rotating left and right. It's also too high, so let's decrease the strength. So it rotates a little bit, but not too much. There we are. Of course, we can go to the top view to make sure that in any point, the lines of the camera are surpassing these corners here, because otherwise we will see that we have a limit there, we don't have ocean. Okay, so we really need to keep that in mind. And this is what's happening. Also, we can maybe add it to the X location. So the camera slides a little to the left and to the right. Let's make this a little bigger. Let's see what we have. And as you can see, basically here, the curve is exactly the same as the other one, and that is not natural. Anything moves exactly the same way in two different axes in a natural way. So what we can do is to change the face here to create a different curve. So now it's something a little more natural, and decrease the strength a little bit. So now I think it's a little better. Can even increase the scale so it moves, but it's really smooth. And let's tweak a little more these ones, like this one, make it bigger, for example. Okay, so I think this looks pretty good. Let's decrease this to see it in real time, see what we have. Okay, it's not bad. So now finally we can go right here and pick the wire. So now we can see the wireframe on top of the water. This is the real wireframe. Now we can just increase the subdivisions here to see exactly what we have. And here we have the final detailed mesh. So it's a lot of polygons right here. And I haven't the anti-aliasing into the into the viewport activated, but maybe if we take a screenshot, you can see it better. Okay, and this way we can take a render animation with the wireframe, just to show how everything is behaving with the wireframe, anti-aliasing and everything, right? And we can see it also in real time. So if we press here, this OpenGL render active viewport, we can set, for example, these measures 100%. So now this will have a more reasonable size. And now in the output, we could select the output, the format of the images, and we can render it. Okay, so let's do it. I have it right here. Let's create with I a new folder, which will be like test sequence. Enter into it, and ocean test viewport. And let's try it out. We press here, and now we should wait frame by frame, and I'll come back when the render is done. Okay, the animation has been already rendered, and as I have in the preferences, I have set up, let's go to the user preferences. There we are. And if we go to the file, here you can see how in the animation player I set up DJV and the folder in which it's installed. So if I go to render here, I can just play rendered animation, and it will open DJV, just loading the current animation. Okay, so I hope you learned a lot from this tutorial. I hope you enjoyed it, and see you on the next tutorial. See you soon. See you again. It's very difficult for me to say goodbye. Did you notice it? It's crazy. Okay, so see you in the next tutorial, and happy blending.